All right, this video series will start with topic 9, which is chemical reactions in stoichiometry. Notice that it corresponds to chapter 6 and chapter 7 in the OpenStax Atoms First, so be sure you're also looking at the textbook for additional information as well as more practice problems. In this video, we're going to be covering section 1, which is an introduction to chemical reactions, which is section 7.1 in your textbook. So to start off, what is a chemical reaction? Chemical reaction is simply a chemical change. It's one in which atoms are rearranging themselves to form new substances. So anytime something new is formed, a chemical reaction has taken effect. So if we take a look at the two images that are below, we need to decide which one is representing a chemical change. So this first one's asking from left to right, would this represent a chemical or a physical change? If I take a look at what's in the first container compared to what's in the second container, I can see that molecularly speaking, we are looking at the same species. It just seems to be there's a different form of it. And so this first example, this would be physical. In the second example, however, we look at the species that we start with compared to what's after. You can see that new substances are being formed. And so in this example, this would be classified as chemical. Now, we don't always have the luxury of being able to see the molecules up close like this. Usually in the lab, we're mixing things in test tubes and beakers, and so we can't see if something actually has been created new based on the molecular structure. So we need chemical indicators to help us figure out whether or not something has actually chemically taken place. I'm going to move my webcam out of the way. So chemical indicators are signs that a chemical reaction may have occurred. Some chemical indicators include production of a gas, which is bubbles. Heat or light. Anytime heat or light is given off by a reaction, that is an indicator that a chemical reaction has taken place. Formation of a precipitate, in other words, formation of a solid. If you mix two substances together and you notice that a solid is forming at the bottom of a beaker or a test tube, that's an indicator that something chemical has taken place. And then finally, a color change. If you mix two things together and notice the color changes, that can indicate that a chemical reaction has occurred. However, it's important to know that the key thing here is that these are indicators. It's not necessarily evidence that actually something new has been created. The only evidence of a new substance is you need to perform chemical analysis, and there are methods to do that, but that's the only 100% sure way to know that a chemical reaction has taken place. But the indicators are helpful in helping us figure out whether a chemical reaction may have occurred. Now, I'm hoping you're familiar with chemical equations. Chemical equations is a systematic way of showing that a chemical reaction, what's involved in a chemical reaction. And so if you look at a couple of the components that are involved in a chemical equation, it's going to show you the compounds involved in the reaction, both before and after. It's going to show you the states of matter. It's going to show you whether or not the energy is exothermic or endothermic. So has energy left the system or is energy being absorbed? And then finally, and most importantly for us when we start to get into the calculations, is it's going to quantify the reaction via coefficients once the reaction has been balanced. And so if we take a look at an example, methane reacts with oxygen to produce carbon dioxide and water. If you take a look, we've got the balanced chemical equation that's right here. You'll notice on the left side of the arrow, you have the reactants. These are the things that are involved before the reaction has taken place. Products are on the right. A few things to note here. Notice that it has to be balanced by putting whole numbers in front. Those are known as coefficients. We'll talk about how to figure that out with balancing in just a moment. But this is an example of a chemical reaction. Let's take a look at another example of a chemical reaction, one that might be a little bit more complex. Okay, so let's take a look at this one right here. And I'm going to move my screen down here. So if you take a look, this is an example of a chemical reaction that is a little bit more in depth. There's a lot of information that it's telling us. So let's piece it out. First of all, by the blue arrows, you'll notice after every single substance, there is a parentheses with some terminology inside. That's going to tell us what the states of matter are for every substance. S stands for solid, L stands for liquid, G stands for gas, and then AQ stands for aqueous. I want to take a quick moment and differentiate between liquid and aqueous. Liquid means that it's the exact substance, but just in the liquid form, whereas aqueous is the substance dissolved in water. So let me give you an example. If I wrote down NaCl, and then I put liquid after that, that's a italicized L. That just means I have sodium chloride or table salt literally melted. That's it. So it's still pure sodium chloride. It just happens to be in the liquid form. That's not a very common thing to see with ionic compounds. More common you're going to see with ionic compounds is that they're going to be aqueous, which means this is dissolved in water. So the NaCl here is dissolved in water, and so really you have a mixture. You don't have a pure substance. So I wanted to differentiate what those two meant. What else do we have? We have the coefficients that are in front. Like I said, those are going to quantify the reaction for us. More specifically, what do the coefficients tell us? They tell us the mole ratio. So what that means is these numbers that are in front here can stand for moles. So 2 moles of aluminum will react perfectly with 6 moles of hydrochloric acid. As a result, that will produce 2 moles of aluminum chloride and 3 moles of hydrogen gas. So the balanced equation that comes from those coefficients, they tell us what the mole ratio is. And that's going to be important when we start doing stoichiometry, which is in a later video. And then finally, sometimes you'll see at the very end of the reaction this delta H. This stands for enthalpy or heat. When we get into a later topic, we're going to start talking about the energy change in a reaction, and we're going to be able to figure out how much energy is given off if it's exothermic or how much energy is absorbed endothermic based on that number. Real quick to note right now, and it'll help us later on, is if the value right here is negative, that tells us that it's exothermic, that it's losing that energy. But if the value is positive, that's an endothermic reaction. That means it's going to be absorbing that energy. We'll talk more about enthalpy in a later topic, so no worries right now, but I just wanted you to be familiar with that. Lastly, I wanted to cover real quickly, and I'm going to keep moving my face around, just a few key things to point out about how can you figure out what the state of matter something might be based on a chemical reaction, right? Because we saw on the previous slide that there's the solid, liquid, gas, or aqueous right after, right? And so there's a few tips and tricks to help you remember what state of matter things might be in. At standard conditions, which is 25 degrees Celsius and 1 atmosphere of pressure, essentially those are the conditions of a regular room. At standard conditions, here are the following states of matter. Metals are going to be solid. The exception for that is mercury. Mercury, Hg, is liquid, but all other metal atoms are going to be solid. Remember your diatomics. There's the 7 diatomics that are right down here. Of the 7, 5 of them are gases: hydrogen, nitrogen, oxygen, fluorine, and chlorine. Bromine is the only diatomic that's liquid. Iodine is the only diatomic that's solid. And then ionic compounds are probably going to be the most common compounds that you see in a chemical reaction, particularly in Chem 151. And so the key thing there is ionic compounds are either going to be solid or they're going to be aqueous. So solid, you obviously know what that means, but aqueous, we just talked about, it's going to be dissolved in water. How will you be able to tell which is which? You're going to look at solubility rules, and solubility rules will be explained in a later video. So that wraps up section 1. I'll see you in section 2.